Okay, so here's the first page of the notes. I'm going to pause for a second while I ask you to show me that you have found the first page of the notes. Square root of 50. What the heck does that mean? I don't really know. Well, I know it's a number, but and I know about what it is. I could tell you what the square root of 49 is, though. The square root of 49 would be 7, because 7 times 7 makes the 49. So would you agree the square root of 50 must be kind of close to 7? A little bit more than 7, in fact, because this is a little bit more than 49, then it must be a little bit more than 7. So would you agree it might be like 7.1 or something like that? Just a little bit more than 7? All right. So when do you use square roots? Well, sometimes you just reduce them. Like the square root of 50, you just reduce it to the square root of 2 times the square root of 25. You know, that's factoring. You've factored before. I told you factoring was the most important thing this year. And here it is again. This times this makes that. That's factoring. If you make it into multiply, it's a factored problem. And why did I pick square root of 25? Because it works nice. 5, and then you put the root 2 after it. 5 root 2. Did you just get what happened there? The square root of 25 was 5. Square root of 2, we leave as square root of 2. So the answer reduced is 5 root 2. I'll give you like the simplest one like that. Go off to the side and put square root of 8. If you can make that into 2 square roots times each other, you'll be able to simplify it really quick. Factoring, again, the biggest thing. That's why I think when they taught you multiply back in 2nd grade, that was the biggest day ever. Because that's what leads to multiply. Multiplying leads to factoring, and factoring is the biggest thing in Algebra 2 and Pre-Calc. So did you know it was 2 times 4? Good. Could I have picked 8 and 1? Yeah, but that really wouldn't have helped. Like square root of 8 and the square root of 1 just goes back to a 1, and then you're just back to where you were. So that doesn't help. This one helps, because that's a perfect square. Final answer is 2 root 2. Because this one's 2. And the leftover that couldn't simplify is root 2, so 2 root 2. All right, let's make sure you got that. Would you please do this one and this one? I'm going to ask you to turn my way and show me, and I'll either say yes or no for every single kid. Square root of 27. Break it into 2 square roots and then simplify it again. Hint, if you don't know what multiplies into 27, 9 does. All right, so once you're done, turn it my way. If you're wrong, that's okay. At least you tried. All right, that's it. Nice job. That's it. Nice job. Yup. You were right in the back. You're right. That's correct. Yup. Except the square root of 9 simplifies further. So otherwise, you're right, though. Yes, that's right. That's right. That's right. That's right. 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 Yes, except square root of 9 simplifies further. Square root of 9, it actually comes out to a nice 1. Yes, that's it. Yes, that's it. That's it. Yep. This time I don't remember if I saw yours. Okay. Yes. Now, you just end with just 3. 3 root 3. All right. So final answer on that was 3 root 3. Because this is root 9, this is root 3, and that's 3. So 3 root 3. All right, that's one thing that you got to do today. That's like one of your 3 things you got to do for today. So that's pretty easy, isn't it? But what if it's something big like 102? Well, then you just think, is there anything that would go into 102? And like, well, 2 does, right? 2 goes into 102 because it's even, so I know it does. So there must be 51 and 2. If it ever does that, 2 prime numbers like this, it's probably not going to work. You know, like I can't simplify this one. You just leave it alone. Because this isn't any better, because neither one of these is what's called a perfect square. The key perfect squares you're looking for and you got to be good at, the square root of 4 is 2. Square root of 9 is 3. See where I'm going with this? The next one's 4, so what's that? Square root of 16. If the next one's 5, what's that? Square root of what? 25, good. If the next one's 6, then that's square root of 36. The next one's 7, what's that one? 49. Okay, these are the ones you should have memorized. And all the way up to 10. So 8 square root of 64. For 9, it'd be the square root of, somebody say it, 81, good. And the last one's 10, which would be square root of 100. That's about as high as you'd ever ask you to do. All of those are called the perfect squares. So if it's any other number than that, like instead of square root of 49, it's the square root of 50, then all you can do is estimate it and say, well, it's a little bigger than 7. And you can go, that's square root of 25 and the square root of 2, which is 5 root 2. And we probably wouldn't even ask you to simplify the square root of 17 because we know that that's not going to break up. And we know that that's not going to make, like there's no way to make it simpler. You just leave it as square root of 17. But this kind, we definitely give you some of those on your homework and on the next test. All right, and here's the next kind of thing. To make sure you really understand that, would you just answer these 6 questions? I'll do the first one for you. It's 5. Just answer those real quick. Marshall, what's square root of 36? Yep. Daniel Kurth, square root of 100? Good. Agenda, square root of 4? Good. I said you wouldn't have to go higher than 10, but this one, just say it if you know it. 11, very good. And square root of 49? 7. All right. So, how do you use square roots on problems like this? If you want to do the opposite of add, you do subtract. They're like, they undo each other. If you had x plus 4 equals 8, you would subtract 4 to undo the plus 4. See, because they're opposites of each other. Well, what's the opposite of squared? Square root. That's the whole point. So how do you get rid of this little squared right here? You square root it on both sides. You square root both sides. And here's the part where some of you, when you learned algebra, you were taught wrong. And I'll say I taught this wrong when I taught algebra a long time ago. It was actually in pre-algebra. And here's why. Because I said it was just x equals, and the 4, square root of 4 is 2, and that wasn't wrong. So far I'm not wrong. Except I would say, and it's plus and minus 2. And that would give the kids the impression there's 2 answers to the square root of 4, and there isn't. There isn't 2 answers to the square root of 4. There's only 1. But the thing I didn't know, and I'm trying to pass along to other teachers here, I know some of the teachers literally in this building have been teaching this way, where they just slap a plus minus here, and they think, I've told the kids the right way to do it. That is not the right way to do it, because the square root of x squared is the absolute value of x. Please write that in there. Put those bars on there, because this is a small thing, but kind of important. I'll give you a small thing that's kind of important. Have you guys been hearing about the drones that are being sighted all over the place in the U.S.? Raise your hand if you know what I'm talking about. That's only like 8 people. All right, in case you don't know, there's been sightings of drones all over the place, some of them in sets of like 50, and they're flying around, and the government locally doesn't know what they are. They don't know who's controlling them. And there'll be like 50 drones flying in formation at 3,000 feet. These are not like little home drones like you might fly in your backyard. These are big ones that are capable of flying way higher and way faster. I know because I have a drone like that. I don't have a big one. I have a normal size one. And these big ones can fly at like 3,000, 4,000 feet. They're not supposed to fly up there without special permission. And yet, even the guy who's in charge of the House of Representatives, okay, like pretty high up in the government, if you're in charge of the House of Representatives, is saying, we don't know who owns these drones. We need to know now. If it's the U.S. government, you've got to tell us. Like, he's the head of the House of Representatives. He doesn't know. So anyway, it's kind of an unusual situation with these drones flying up there. But here's a little bit more information. Kind of like I'm telling you here, this absolute value bar here, these are a big deal. Little piece of information. They have lights on them. And those lights that are on them are in the official way that you have to light a drone if you're going to follow the FAA rules. If they were secret drones, do you get that they wouldn't need lights? They don't need lights to fly. If you're flying a drone, especially probably remotely or using AI, they don't need lights on them to be able to fly. And so the lights are on them so that other people can see that they're there, so that you don't run into it. Like if you're a plane flying along, you don't want to hit a drone. And so that makes me think that since they have lights on them, and they light themselves up so that you can actually see them even at night, they're not trying to hide, which makes me think maybe we'll find out. We'll find out. I'm sure we'll find out soon, because like all these government officials are like, tell us what's going on. We don't know who owns these drones. We don't know if it's our own government flying them. So anyway, there's a lot of like, what on earth is happening? But the little piece of information that they're lit, and they're lit in a very special way, like with a red light and a not red light, like a white light, that makes you think that they are officially made like to follow the rules of the government, which means maybe they're government drones. Who knows? Anyway, this little detail that this needs an absolute value bar right here should tell you that there's two things that can work in here. 2 works in here, so x equals 2. And -2 also works in here, so x equals -2. That's why there's 2 answers. See, I don't want you to think square roots have 2 answers, because they don't. The square root of 4 is just 2. That's just 2. The reason there's 2 answers is because when you do this square root over here, there's absolute value bars on it, and that means that 2 different things could work. If we back up to the original problem, x squared equals 4. Do you get if I put a 2 in here, it works? But also, if I put a -2 in here, in a parentheses, because that's what an x is an empty parentheses. If I put that -2 in, it'll also work. So, the most common wrong answer on the test is going to be, they're going to go like this, and some poor kid's just going to go, oh, I can do this in my head, and x is 6. There's 2 answers. Square root, absolute value of x is 6. And that tells you, oh yeah, it could either be x equals 6 or x equals -6. That's how you do absolute values. All right, so there's 2 answers to almost every problem today. Did you catch that? There's 2 answers to almost every problem today, because almost every problem has an x squared. And one more thing you need to know about that is if it has an x squared, then that's how many answers there's going to be. 2. And if it says x to the third, then there'd be 3 answers to an equation that has x to the third in it. That tells you how many answers you have. If you've never caught that before, it's true. So you know when you were little and somebody just told you, like, here's a little equation, Johnny. X plus 1 equals 3. And you're like, oh, so x must be 2. That was your easiest equation. Look, it had only one answer because it was x to the 1. And now, when you see something that has x to the 5th in it, there are 5 answers to a problem like that. And if I want it to equal like 0, there's going to be 5 answers or roots. Sometimes they're imaginary, sometimes they're real, but this is critical, knowing that that's how many answers you got. Okay, so since most of our problems have x squared today, most of our problems have 2 answers. Moving on to this page. See how it's got an x squared in it? All right, next thing, everybody get to this page. Some of you haven't moved your hand yet, so I know you can't be at this page yet. I'd like you to write PEMDAS like I am. Do you remember that when you are solving an equation, you're doing PEMDAS but backwards? You always start your equations like, I'm going to add something to both sides, or subtract something from both sides. If you've never processed this before, you are doing the lowest level of PEMDAS. So if I'm going to solve this, I'm going to do the lowest level of PEMDAS, which is, can I add or subtract something? Yeah. Everybody put plus 25 here and here. I added 25 to both sides. I'm trying to get the x alone. So I'm going to get rid of this. Eventually, I'll get this completely alone. All right, now I have x plus 3 quantity squared equals 25. And then, do you get this minus 25? Just, I did tell you for a while that in my high school we would just move it to the other side and make it positive. So there it is. And I just changed minus to plus by accident. Sorry about that. There's a minus right there. Was minus, still minus. Okay, so there. I just moved the 25 over. Now I'm going to square root both sides. Because square root undoes squared. Well, you just skipped over multiply and divide. You're right. I didn't need to multiply or divide to try to solve this equation. I had to get rid of the exponent. And the last thing I'm going to do is what's in the parentheses. See, the P is last. See the stuff in the parentheses? I haven't touched it yet, and I won't until the very end. That's the last thing I'll do. All right, so square root undoes squared, and this is absolute value. So important. Square root of 25 is 5, and it's only one thing. No, it's not plus and minus 5. That would be wrong. Square root of 25 is just 5. And then you split it into two equations. X minus 3 is 5, and x minus 3 is negative 5. There's your two little baby equations that come out, and you have to solve these little bite-sized equations by adding 3 to both sides. And my final answer is x equals 8, and x equals negative 5 plus 3, which makes negative 2. Now, if your life depended on it, could you check and make sure that 8 actually worked? Sure you could. Just go stick an 8 in here. And 8 minus 3 is 5, and 5 squared is 25, and 25 minus 25 equals 0. I checked. It actually equals 0. Cool. And negative 2 would also work. All right. That was intense. This first one, remember, you always start with, can you add or subtract anything? And I could, and it would make it better if I subtracted 5. And is x squared minus, or sorry, 41 minus 5, is that some random number? Of course not. It's 36, and that happens to work out perfect. And if you try to do it in your head right now, you're going to think the answer is just 6, and you're going to be wrong. So don't try to do it in your head. Square root, square root. Absolute value. If I taught you nothing else today, if you could only remember one thing. When you square root a variable, put absolute value bars on it. Because I think most of you knew the square root of 36 coming into today is just 6. And then this tells you there's two answers. X equals 6, x equals negative 6. There's your two answers. That's it. And there we are, 20 minutes in, and you already have learned everything that you have to know for today. And now it's just like practicing it. So let's practice it. Is there any add or subtract I could do that would make this better? Nope. Then you move up to multiply or divide. Is there any multiply or divide I could do to make this better? Yes. What could I do? Divide by 2. So a squared equals 18 divided by 2 is 9. Yeah, stay away from the front row. Thank you. Square root, square root. Lipnick, I said if there was only one thing you would remember. It's how to do this part. Can you tell me what happens when you square root a squared? Nice. He remembered. Pressure was on. Osberg, what's the square root of 9? Yep. From here, how do I get the answers, Zane? A equals 3. A equals negative 3. Yep. Because absolute values always have two equations. All right. This page. We already did this before. I'm just going to remind you. Let's say the problem just has, you're at the end, you got square root of 20, and you're like, oh, wait a minute. Am I supposed to know the answer to that one? No, because it's not a perfect square. But you're supposed to know it's root 4 and root 5. So that's 2 root 5. And you get how I did that? Don't forget, that's part of the assignment too, is knowing how to simplify those. So this is root 9 and root 5, so that'd be 3 root 5. First you start with 2 square roots. Then you simplify one of them. Because this is the times, this is factoring. All right, good on that. Good enough on that. And the last page that I'm going to ask you to do. On that first one. Mr. Kist, is there anything you could add or subtract that would make this problem better? Add 10. Sam Lowe, is there anything you could add or subtract to make this better? No, we already did there, add or subtract. How about multiply or divide?
Would you divide 7?
Correct. $35 divided by 7 is 5. If you didn't know that, it's okay. You'd have a calculator. But no calculator is going to be able to solve this one. Well, there are actually calculators, but no calculator we would allow on a test can solve this one. You got to know you square root it. And then this is the trickiest step. Mara H., can you tell me this part right here? Okay, absolute value of R. When you square root a variable, you get the absolute value. Now, the square root of 5 is just the square root of 5. You should know that that's one that you can't simplify. Do you think I expect you to memorize the answer is like 2.437? No, of course not. You just say square root of 5. Amina, have you caught on to the whole split it thing and tell me the two answers? And the other one? Perfect. There you go. The middle one, Caden. Oh, danger. I'm going to ask you a question, but be careful. Is there anything you could add or subtract at this point? No, you are correct, because it's trapped inside the parentheses, and parentheses are last. Is there anything you could multiply or divide? No. Is there anything you could do to do exponents? Because that's what we're doing, is going through this. And there was nothing you could add or subtract. There was nothing you could multiply or divide, but there is exponents. How do you get rid of that squared?
Absolute value.
Now this is, well, it's going to have an absolute value, but it was, you should have said square root. You square root it. And then it becomes absolute value. Now this one's extra tricky, Osberg, because do you get that the square root of 8 isn't a nice clean number, but we could simplify it? 2 square roots, what do you think they are?
2 and 4.
Yep. And then simplify it more.
2 square root 2.
Perfect. Okay, now I'm almost done. I just have to make my 2 equations for this. X minus 1 is 2 root 2, and x minus 1 is, I'm going to erase this for a second. Do you get these 2 equations are the exact same thing all the way up to the equals? And the only difference is you're going to put a 2 root 2 here and a negative 2 root 2 here. Other than that, those equations were identical. It's just that you make one of them positive and one of them negative. These aren't that hard. There's just a couple steps you got to learn. Adding 1, adding 1, adding 1, adding 1. Now I underlined this. I'm not dividing, so I'm going to get rid of my underline there. And these 10 cancel, and then I get that. Those are not like terms. So I'm going to write it as 1 plus 2 root 2. You could write it the other way also. But I'm going to put the number first. I think you'll see why in a second. And this one's the same way. That cancels. 1 minus 2 root 2. So some people like to put these together. First of all, I'm fine right here. You could be done. But if a kid wrote 1 plus and minus this 2 root 2, I would think, ooh, that kid's pretty sharp. See how this is? There's one with a plus and there's one with a minus. And so if you wanted to, you could say 1 plus or minus 2 root 2. Again, that last red step, not required. It's just going to make you a little more proving that this kid's on top of the class. Because they even caught that little detail that you can add, make a plus minus if you want. Because there's 1 plus and there's 1 minus. All right, I know that was intense. We're on the last one, though. Is there any add or subtract that you could do to start off this problem, Zane? What could you do? Correct. Is there any multiply or divide that you could do to make this problem better? Lindholm. Correct. We did the add subtract. 40 divided by 2 is 20. PEMDAS, I'm just showing you what we've been doing. We did the add or subtract step. Then we did the divide step, which is the multiply divide step. Now we're on the exponent step. Okay, can you get rid of squared? Yeah, the whole point of today. Square root. And I said if there was only one thing you'd remember. I hope you'd remember this is the absolute value of x plus 3. Because if you just take off the square root, which is what a lot of kids are going to do, you'll only get one answer and you'll get it wrong. And the square root of 20, that's supposed to be something you already knew. Root 4, root 5, 2 root 5. I know for some of you that's new. It's supposed to be something you already knew. And then the split at the end, that's what makes these now the hardest algebra problems we have ever done. I just said that last unit, but that was true then. These are harder. There's a minus in here that I never drew, and that's important. That one's positive, that one's negative. And if you're extra sharp, a few of you are going to be like, I can prove to you I can remember that. Negative 3 plus and minus 2 root 5. Optional. The way we would want you to do it if you were in honors. But we don't require it. I'm just showing it to you because I think some of you can handle it. But this would have been okay. Should have the x at the beginning. And this should actually say x equals technically. Okay. I taught you everything. Now, for some of you, you're gonna need to shift gears when we start the homework for today, because you need to get your basic 20 done, because you didn't get it done over the weekend, and it's your top priority today, is to finish that. Okay, but for everybody, let's at least start today's homework, because when you're started, I think you're about halfway done. So would you please find the Schoology quiz, and there's a thing with the Schoology quiz that is the problems, so that you can do them on scratch paper. In a moment, I'm going to ask you to show me that you have got a split screen going between the PDF that has the problems on it and the Schoology quiz where you're supposed to answer and actually type in the answers there. So a split screen right now. I can show you how to do it personally. I bet you'd rather do it yourself. So on your split screen, number 1 on the PDF, it says square root of 45. And on the Schoology quiz side, you just have to answer the question over there. Well, over here on the PDF, I'd say root 9 and root 5, which is 3 root 5. And so that's what you type in here. But how do you type it on Schoology? 3 SQRT 5. Now, I don't know, honestly, if you need a parenthesis around that or not, so I'm going to check. I'm looking at the answers of the Schoology quiz right now. Editing, so I can see whether we require a parentheses or not. This does not have any parentheses around the 5. So 3 SQRT 5 is the first answer. No spaces. You type exactly that. And there's your first answer to the Schoology quiz. In a moment, I'll be cruising around. If you're stuck on how to get split screen going, I will help you. And that's all I got for you for today.